What if I told you that the James Webb Space Telescope might have just photographed something that shouldn't exist? Something from before time itself began? Right now, floating in the cold vacuum of space, Webb is collecting photons that have been traveling toward us since before stars existed, before galaxies formed, maybe even before the Big Bang itself. And these ancient whispers of light might be telling us a story so profound, it could rewrite everything we thought we knew about existence. I'm talking about the possibility that Webb has captured light from before creation. Not just the early universe, but something that predates our entire understanding of when time and space began. Today, we're going to dive deep into this mind-bending possibility, explore what it could mean for our understanding of reality, and examine whether we're standing on the precipice of the greatest discovery in human history. But first, I want to know where you're watching from and what time it is in your part of the world. Drop a comment below telling me your location and the current time. I love connecting with viewers from all corners of our planet as we explore the mysteries of the cosmos together. The revolutionary eye in the sky. Let's start with what makes the James Webb Space Telescope so extraordinary. When Webb opened its golden eyes for the first time in 2022, it didn't just take pretty pictures. It fundamentally changed how far back in time we could see. Think about that for a moment. Every time you look at a star, you're literally seeing into the past because light takes time to travel. The sun's light takes about 8 minutes to reach us, so we see the sun as it was 8 minutes ago. Webb takes this time travel to an extreme that would make even the most creative science fiction writer pause. Its primary mirror, composed of 18 hexagonal segments coated in gold, is specifically designed to capture infrared light, the stretched-out, reddened light from the most distant objects in the universe. This infrared capability is crucial because as the universe expands, light from distant objects gets stretched to longer wavelengths, shifting from visible light into the infrared spectrum. But here's where it gets truly incredible. Webb can see objects so far away that their light has been traveling toward us for over 13 billion years. That means Webb is literally photographing the universe when it was less than 1 billion years old, a cosmic infant compared to its current age of 13.8 billion years. Every deep field image Webb captures is a time machine, showing us galaxies as they existed when the universe was young, wild, and completely different from what we see today. The telescope's location at the L2 Lagrange point, about 1.5 million kilometers from Earth, provides it with an unobstructed view of the cosmos without interference from our planet's atmosphere or heat signature. This positioning allows Webb to maintain the ultra-cold temperatures necessary for its infrared detectors to function with unprecedented sensitivity. What's revolutionary isn't just how far Webb can see, but how clearly it can see. Its resolution is so precise that if Webb were positioned on Earth, it could theoretically read the small print on a coin from nearly 40 kilometers away. When you combine this incredible resolution with its ability to peer through cosmic dust that would blind other telescopes, Webb becomes our most powerful tool for archaeology. Cosmic archaeology. Before we go deeper into this cosmic mystery, if you're enjoying this journey to the edge of existence, hit that subscribe button and ring the bell. We're about to explore concepts that push the very boundaries of human understanding, and trust me, you won't want to miss what's coming next. The Cosmic Dawn and Dark Ages. Now, to understand how Webb might be seeing before creation, we need to understand what came before the first stars and galaxies. After the Big Bang, the universe went through several distinct phases, each with its own character and mysteries. First came the era of nucleosynthesis, when the universe was hot enough for protons and neutrons to fuse into the first light elements, primarily hydrogen and helium. This happened within the first few minutes after the Big Bang. Then, for about 380,000 years, the universe was essentially opaque, a hot, dense plasma where photons couldn't travel freely because they kept bouncing off free electrons. But then came recombination, not a romantic reunion, but the moment when the universe cooled enough for electrons to combine with protons and form neutral hydrogen atoms. Suddenly, photons could travel freely through space for the first time. This moment released the cosmic microwave background radiation that we can still detect today. It's essentially the afterglow of the Big Bang, the oldest light in the universe that we can observe directly. Here's where things get really interesting. After recombination came what cosmologists call the Dark Ages, not because anything sinister happened, but because there were literally no light sources in the universe. For hundreds of millions of years, the cosmos was filled with neutral hydrogen and helium gas, but no stars, no galaxies, no quasars, nothing that could produce light. The universe was dark, cold, and seemingly lifeless. The Dark Ages lasted until gravity began pulling together the first clumps of matter dense enough to ignite nuclear fusion. This marked the beginning of what we call the Cosmic Dawn, the epoch when the first stars blazed to life. These weren't stars like our sun. They were massive, short-lived giants that burned through their nuclear fuel in just a few million years before exploding as supernovas, seeding the universe with heavier elements and clearing bubbles of ionized gas around them. Webb is specifically designed to observe this cosmic dawn period. Its infrared vision can penetrate the cosmic dust and gas to see the formation of the very first galaxies and supermassive black holes. But here's where our story takes a fascinating turn. What if Webb is seeing even further back than that? What if it's capturing signals from the Dark Ages themselves, or even from before the cosmic microwave background was released? The traditional view holds that we can't see anything before the cosmic microwave background because the universe was opaque before then. But what if that's not entirely true? What if there are other types of signals, other forms of information that could travel from even earlier times, beyond the observable horizon? This brings us to one of the most mind-bending questions in modern cosmology. What lies beyond the observable horizon? The observable universe, everything we can theoretically see, is limited by the speed of light and the age of the universe. Light from more distant objects simply hasn't had time to reach us yet. But that doesn't mean nothing exists beyond that horizon. Think about it this way. If you're standing in the middle of a vast ocean, your horizon extends only a few kilometers in every direction. That doesn't mean the ocean ends at your horizon. It just means you can't see beyond it. The same principle applies to the universe, but instead of being limited by the curvature of the Earth, we're limited by the finite speed of light and the finite age of the cosmos. But here's where things get truly speculative and exciting. What if Webb is detecting something that challenges our understanding of this cosmic horizon? What if there are phenomena from before the Big Bang that can somehow influence what we observe today? Recent theoretical work in cosmology has proposed several fascinating possibilities. Some models suggest that our Big Bang might not have been the absolute beginning of everything, but rather a transition point in an eternal, cyclical universe. In these models, universes expand, contract, and then undergo a big bounce that creates a new universe. If this is true, then information from previous universe cycles might somehow leak through to our current cosmos. Other theories propose that our universe is just one bubble in an infinite multiverse, where big bangs are happening constantly, creating new universes all the time. In some versions of these theories, the collision between universe bubbles could create observable signatures that Webb might be able to detect. Then there are even more exotic possibilities involving concepts like quantum foam, virtual particles, and the fundamental nature of space-time itself. At the Planck scale, the smallest meaningful unit of space and time, our current understanding of physics breaks down completely. Quantum mechanics and general relativity, our two most successful theories, become incompatible at these scales. I want to hear your thoughts on this. Do you think it's possible that Webb could detect signals from before the Big Bang? Or do you think the idea of before the Big Bang doesn't even make sense? Share your perspective in the comments. I love seeing how different minds approach these cosmic puzzles. What's particularly intriguing is that Webb's unprecedented sensitivity might be picking up extremely faint signals that previous telescopes simply couldn't detect. Every time we've built a more powerful telescope, we've discovered things we didn't expect. Radio astronomy revealed pulsars and quasars. X-ray astronomy showed us black holes and neutron stars. What might infrared astronomy at Webb's level of sensitivity reveal? The answer might lie not in what Webb sees, but in what it doesn't see where we expected to see something, or in subtle patterns in the cosmic microwave background that suggest influences from earlier times. Sometimes the most profound discoveries come not from dramatic new observations, but from tiny discrepancies that hint at deeper truths. The physics of before. To really grapple with whether Webb could see time before creation, we need to confront one of the most fundamental questions in physics. What does before the Big Bang even mean? This isn't just a technical question. It challenges our most basic assumptions about the nature of time itself. In Einstein's general relativity, space and time are interwoven into a four-dimensional fabric called spacetime. The Big Bang theory suggests that spacetime itself began at that moment, approximately 13.8 billion years ago. If spacetime began then, asking what came before might be like asking what's north of the North Pole, a meaningless question because there's no north once you reach the northernmost point on Earth. But this classical view might be too simplistic. Modern physics suggests that at the extreme conditions present at the moment of the Big Bang, our current theories break down completely. The densities and temperatures were so extreme that quantum effects would have dominated, and we don't have a complete theory that successfully combines quantum mechanics with general relativity. This gap in our understanding opens the door to fascinating possibilities. Loop quantum gravity. One approach to quantum gravity suggests that the Big Bang might have been preceded by a big bounce, the collapse of a previous universe that reached a minimum size before expanding again. In this model, time extends infinitely into the past, with an endless series of expanding and contracting phases. String theory offers its own exotic possibilities. Some versions suggest that our universe exists on a higher dimensional membrane, or brane, and that the Big Bang was triggered by the collision of two branes in hyperspace. The physics of these higher dimensions might allow information to travel between brane collisions, potentially creating observable signatures in our current universe. Even more speculatively, some theories propose that the universe undergoes phases where the direction of time itself changes. In these models, what we perceive as the beginning might actually be a turning point where time reversed direction, and before the Big Bang might refer to a time reverse phase of the same universe. The quantum nature of reality adds another layer of complexity. At the quantum level, particles can tunnel through energy barriers that classical physics says they can't cross. Virtual particles pop into and out of existence, seemingly violating conservation of energy for brief moments. If the universe itself emerged from quantum fluctuations, then the boundary between something and nothing becomes far more blurred than our everyday experience suggests. This is getting pretty deep, isn't it? If your mind is being blown by these possibilities, make sure you're subscribed because we explore mind-bending physics concepts like this regularly. And hit that like button to let me know you're following along with these cosmic thought experiments. Here's where Webb comes in. If any of these exotic scenarios are correct, they might leave subtle fingerprints in the cosmic microwave background radiation, in the distribution of galaxies, or in other observable phenomena. Webb's incredible sensitivity might be able to detect these fingerprints where previous instruments couldn't. For example, if our universe underwent a big bounce from a previous contracting phase, the gravitational waves from that event might have left polarization patterns in the cosmic microwave background. If our universe collided with another brane, the shock waves might have created temperature fluctuations that we could observe today. If quantum effects were significant during the universe's earliest moments, they might have left statistical signatures in how matter is distributed throughout the cosmos. The key insight is that, before creation, might not mean before the Big Bang in a temporal sense, but rather refer to physics operating under conditions so extreme that our normal concepts of space, time, causality, and existence break down completely. Webb's unprecedented discoveries. Let's examine what Webb has actually observed that's challenging our understanding of the early universe. Since beginning its science operations, Webb has made several discoveries that have forced astronomers to reconsider their models of how the universe evolved. One of the most surprising findings has been the discovery of fully formed, massive galaxies existing much earlier than expected. According to our previous models, galaxies should have taken much longer to assemble into the large, structured systems that Webb has observed. These galaxies appear to be too big, too organized, and too metal-rich for their age. It's as if Webb found a fully grown oak tree in a nursery where only saplings should exist. These massive early galaxies pose a serious challenge to our understanding of cosmic evolution. Galaxy formation is supposed to be a gradual process, with small clumps of dark matter slowly accumulating gas and dust, forming the first stars, and then gradually building up into larger structures over hundreds of millions of years. But Webb is seeing galaxies that appear to have bypassed this gradual process entirely. Even more intriguing are the supermassive black holes that Webb has detected in these early galaxies. Black holes of this size should have taken billions of years to grow, yet Webb is finding them when the universe was less than a billion years old. Some of these black holes contain more mass than a billion suns, despite existing at a time when there hadn't been enough time for them to grow through normal accretion processes. This has led some astronomers to propose that these supermassive black holes might be primordial, formed directly from the collapse of massive gas clouds in the very early universe, rather than growing from smaller stellar mass black holes. But even this explanation pushes the boundaries of what we thought was possible in the early cosmos. Webb has also detected unexpected chemical compositions in early galaxies. The first stars in the universe should have been made almost entirely of hydrogen and helium, with only trace amounts of heavier elements. But Webb is finding significant quantities of elements like carbon, oxygen, and nitrogen in galaxies that formed very early in cosmic history. This suggests that the first generations of stars lived and died much more rapidly than we expected, or that there were processes occurring in the early universe that we don't understand. Perhaps most mysteriously, Webb has observed structures in the cosmic microwave background, the afterglow of the Big Bang, that seem to extend beyond what should be the observable horizon. These structures appear to be correlated across regions of space that shouldn't have been in causal contact with each other at the time the cosmic microwave background was formed. What do you think these discoveries mean? Are we missing something fundamental about how the early universe worked, or could these observations be pointing toward physics beyond our current understanding? Let me know your thoughts in the comments below. These anomalies might have conventional explanations that we haven't thought of yet, but they might also be telling us that our standard model of cosmology is incomplete. If the universe went through phases or processes that we don't account for in our current models, it could explain why Webb is seeing things that seem impossible according to our timeline of cosmic evolution. The possibility that these observations are connected to pre-creation physics becomes more plausible when we consider that the conditions in the very early universe were so extreme that they might have been influenced by whatever came before. If information or energy from a previous cosmic phase somehow influenced the formation of the first structures, it could explain why Webb is seeing galaxies and black holes that appear too advanced for their age. The information problem. One of the deepest puzzles in understanding what Webb might be seeing involves what physicists call the information problem. This isn't just about data storage, it's about the fundamental nature of reality itself and whether information can be created or destroyed. In quantum mechanics, information is conserved. This principle, known as unitarity, means that if you know the complete quantum state of a system at any point in time, you can in principle calculate what it was at any earlier time or what it will be at any later time. Information about the past is encoded in the present, even if it's scrambled or hidden in ways that make it practically impossible to decode. This principle leads to a profound question. If information is truly conserved, then information about any pre-creation state should somehow be encoded in the current state of the universe. The challenge is figuring out how to read that information. Think of it like this. Imagine you have a perfectly mixed cup of coffee and cream. Even though the coffee and cream appear uniformly mixed, in principle, all the information about their initial separate states is still there. It's just encoded in the precise positions and velocities of every molecule in the cup. With perfect knowledge and infinite computing power, you could theoretically unmix the coffee and cream to recover their original states. The universe might work the same way. Even if the Big Bang scrambled all information about any previous state beyond recognition, that information might still be there, encoded in subtle patterns that we're only beginning to learn how to detect. This is where Webb's unprecedented sensitivity becomes crucial. Previous telescopes might have been like looking at our coffee cup from across the room. You could see that it's brown, but you couldn't detect the subtle patterns that encode information about the original coffee and cream. Webb is like examining the cup under a powerful microscope, potentially revealing patterns that were always there but were too subtle to detect before. Some theoretical physicists have proposed that information about pre-Big Bang states might be encoded in the cosmic microwave background radiation in ways that we're only now developing the tools to analyze. The temperature and polarization patterns in this ancient light might contain hidden messages from whatever came before, written in a cosmic code that we're still learning to read. Other possibilities involve gravitational waves, ripples in space-time itself that can carry information across vast distances and time spans. While we've only recently developed the ability to detect gravitational waves directly, Webb might be seeing their effects on the formation and evolution of early cosmic structures. We're diving deep into the fundamental nature of reality here. If you're finding this exploration fascinating, make sure you're subscribed and hit that notification bell. We regularly explore the deepest mysteries of physics and cosmology, and you won't want to miss future episodes. There's also the possibility that information from pre-creation states might be encoded not in electromagnetic radiation or gravitational waves, but in the structure of space and time itself. Some theories propose that space-time has a kind of memory, that extreme events can leave permanent impressions in the fabric of reality that influence how matter and energy behave billions of years later. If this is true, then Webb might be seeing the effects of this space-time memory in the unexpected properties of early galaxies and black holes. The reason these structures appear too advanced for their age might be that they formed under the influence of information patterns left over from whatever preceded our universe. The quantum vacuum, the seemingly empty space between particles, might also carry information from previous cosmic phases. Quantum field theory tells us that what we think of as empty space is actually seething with virtual particles and quantum fluctuations. These fluctuations might be influenced by boundary conditions set by pre-creation physics, creating subtle biases in how matter and energy organize themselves. This perspective suggests that Webb isn't just looking back in time, It's potentially reading a cosmic library where the history of everything that ever existed is permanently archived in the structure of reality itself. The multiverse connection. The possibility that Webb is detecting traces of time before creation becomes even more intriguing when we consider multiverse theories. Rather than our Big Bang being the absolute beginning of everything, it might have been just one event in an infinite ocean of cosmic creation and destruction. In eternal inflation theory, our observable universe is just one bubble in an infinitely expanding multiverse where Big Bangs are happening constantly. In this picture, space-time itself is like a cosmic foam, with new universes budding off from quantum fluctuations in the inflation field. Our universe isn't the first, and it certainly won't be the last. This theory has profound implications for what Webb might be observing. If our universe bubble collided with another universe bubble during its early expansion, the collision would have left distinctive signatures, circular patterns in the cosmic microwave background, unusual galaxy distributions, or other anomalies that we might be able to detect with sufficiently sensitive instruments. Some cosmologists have claimed to identify such collision signatures in data from the Planck satellite, though these claims remain controversial. Webb's superior sensitivity and resolution might be able to confirm or refute these tentative detections, potentially providing the first direct evidence for the existence of other universes. But the multiverse scenario raises even more exotic possibilities. If universes can collide or interact, then information from other universes might leak into our own. This could explain some of the anomalies Webb has observed. Structures that appear too advanced for their age might have been influenced by information or energy from neighboring universe bubbles. The concept gets even stranger when we consider the possibility of universe recycling. Some multiverse models suggest that when universe bubbles collide, they can merge or fragment, creating new universes that inherit properties from their predecessors. In this scenario, our universe might contain information not just from its own history, but from the histories of previous universes that contributed to its formation. The multiverse is one of those concepts that either excites people or makes them skeptical. What's your take? Do you think the multiverse is a legitimate scientific concept, or is it more like science fiction? And if other universes do exist, what do you think they might be like? Share your thoughts. I love hearing different perspectives on these mind-bending ideas. There's also the fascinating possibility of universe genealogy, the idea that universes reproduce and evolve, with each generation inheriting slightly modified physical laws from its parents. If this is true, then our universe might contain genetic information, so to speak, from a long lineage of predecessor universes stretching back through infinite generations. Webb might be detecting signatures of this cosmic genealogy in the values of physical constants, the properties of dark matter and dark energy, or the statistical patterns in how matter is distributed throughout space. These signatures would be incredibly subtle, like trying to detect your great-great-grandfather's influence on your facial features, but they might be there nonetheless. The quantum mechanical aspect of multiverse theories adds another layer of complexity. In the many-worlds interpretation of quantum mechanics, every quantum event splits the universe into multiple parallel realities. This creates an infinite branching tree of possible universes, all equally real from their own perspectives. If this interpretation is correct, then Webb might not just be seeing into the past of our single universe, but potentially detecting quantum interference effects between parallel versions of cosmic history. The anomalies in early galaxy formation might be the result of quantum superposition effects operating on cosmic scales, our universe existing in a quantum superposition with alternate versions where galaxies formed differently. These ideas push the boundaries of what we traditionally consider science, but they're grounded in serious mathematical frameworks developed by leading theoretical physicists. The key insight is that if any of these multiverse scenarios are correct, They would leave observable signatures that advanced instruments like Webb might be able to detect. The quantum nature of time. To fully understand how Webb might be seeing before creation, we need to grapple with perhaps the strangest aspect of modern physics, the quantum nature of time itself. Our everyday experience tells us that time flows smoothly from past to future, but quantum mechanics suggests that reality at its most fundamental level is far stranger than our intuitions suggest. In quantum mechanics, particles don't have definite properties until they're measured. They exist in superpositions of multiple possible states simultaneously. This principle might apply not just to particles, but to the universe as a whole, including its history. The past might not be as fixed and definite as we assume. Some interpretations of quantum mechanics suggest that the act of observation doesn't just reveal pre-existing properties, but actually determines them retroactively. This is the basis of delayed choice experiments, where the decision about how to measure a particle can apparently affect its behavior even after the particle has already passed through the measuring apparatus. If this principle applies on cosmic scales, then Webb's observations might not just be revealing the early universe as it was, but potentially influencing how it was. The very act of looking back in time with unprecedented precision might be retroactively determining aspects of cosmic history that were previously in quantum superposition. This leads to the mind-bending possibility that, before creation, exists in a quantum superposition of multiple possible states, and Webb's observations are causing this superposition to collapse into a definite history. In this view, the universe's past is being continuously created by present-day observations, and Webb might be participating in the ongoing creation of cosmic history. The concept of quantum tunneling adds another layer to this puzzle. In quantum mechanics, particles can tunnel through energy barriers that classical physics says they can't cross. If the universe itself emerged through quantum tunneling from a previous state, then information about that previous state might have tunneled through the apparent barrier of the Big Bang. This tunneling information might manifest as subtle violations of our expectations about early cosmic evolution, exactly the kind of anomalies Webb has been observing. Galaxies that formed too quickly, black holes that grew too massive, chemical compositions that evolved too rapidly. All of these might be signatures of information that tunneled through from whatever preceded our current cosmic phase. These quantum concepts are pretty mind-bending, aren't they? If you're enjoying this deep dive into the nature of reality, smash that like button and let me know in the comments which of these ideas you find most intriguing. And definitely subscribe if you want more content that pushes the boundaries of human understanding. The holographic principle, developed from string theory and black hole physics, suggests that all the information in a three-dimensional region of space can be encoded on its two-dimensional boundary. This principle might apply to the entire universe. All the information about the universe's interior might be encoded on its boundary at the cosmic horizon. If this is true, then Webb might be reading information from this cosmic hologram, potentially including information about pre-creation states that influence the boundary conditions of our universe. The telescope's ability to probe the cosmic horizon with unprecedented detail might be allowing us to decode aspects of this holographic information that were previously inaccessible. The concept of emergent time suggests that what we experience as the flow of time might be an emergent property of more fundamental, timeless quantum processes. In this view, the universe doesn't evolve through time so much as exist as a static four-dimensional structure where past, present, and future all coexist simultaneously. From this perspective, Webb isn't looking back into the past, but rather accessing different regions of this eternal four-dimensional reality. Before creation might refer not to an earlier time, but to deeper layers of this timeless quantum structure that became encoded in what we perceive as the early universe. Dark matter and dark energy clues. One of the most profound mysteries in modern cosmology involves the nature of dark matter and dark energy, which together comprise about 95% of the universe. These invisible components might hold crucial clues about what Webb is detecting from the universe's earliest epochs. Dark matter, which makes up about 27% of the universe, reveals itself only through its gravitational effects. It doesn't emit, absorb, or reflect light, making it effectively invisible to telescopes. Yet without dark matter, galaxies wouldn't have formed at all. There wouldn't have been enough gravitational pull to collect ordinary matter into the structures we see today. Webb's observations of early galaxy formation are providing new insights into how dark matter behaved in the primordial universe. The unexpected maturity of early galaxies suggests that dark matter might have clumped together faster than our current models predict, or that there might be additional forces or interactions that we don't understand. Some theories propose that dark matter consists of particles left over from a previous cosmic cycle or universe. If this is true, then the dark matter we observe today might be fossils from, before creation, remnants of whatever preceded our current universe that somehow survived the transition through the Big Bang. The distribution of dark matter throughout the universe might encode information about these pre-creation conditions. Webb's detailed observations of how galaxies cluster and move might be revealing patterns in dark matter that trace back to processes that occurred before conventional space and time began. Dark energy presents an even deeper mystery. This mysterious force, which makes up about 68% of the universe, is causing the expansion of space to accelerate. Unlike gravity, which pulls things together, dark energy seems to push everything apart with ever-increasing strength. The nature of dark energy challenges our understanding of fundamental physics. If it represents the energy of empty space itself, then quantum field theory predicts it should be enormously larger than what we observe, off by a factor of 10 to the power of 120, making it arguably the worst prediction in the history of physics. Here's a question that might blow your mind. If 95% of the universe is made of stuff we can't see or understand, what does that say about the limits of human knowledge? Are we like ants trying to understand quantum mechanics? Or do you think we'll eventually figure out these cosmic mysteries? Let me know your thoughts. Some cosmologists have proposed that dark energy might be evidence of our universe's interaction with other universes in a multiverse. If our universe is embedded in a higher dimensional space containing other universe bubbles, the gravitational effects of these other universes might manifest as the dark energy we observe. This possibility suggests that Webb's observations of cosmic acceleration and large-scale structure might be indirect detections of other universes, essentially seeing shadows cast by realities beyond our own. The patterns in how dark energy influences cosmic evolution might encode information about the broader multiverse structure that contains our universe. Another intriguing possibility is that dark energy represents the memory of whatever came before the Big Bang. Some theories suggest that the quantum vacuum, the seething foam of virtual particles that fills apparently empty space, might retain information about previous cosmic phases. This information could manifest as the dark energy field, creating a cosmic acceleration that reflects the properties of pre-creation states. The coincidence problem in cosmology adds another layer to this mystery. Dark energy appears to have begun dominating the universe's evolution relatively recently in cosmic history, just when intelligent life was emerging. This timing seems too convenient to be mere chance, leading some theorists to propose anthropic explanations or suggest that dark energy's behavior is somehow connected to the emergence of consciousness or observation. If dark energy is indeed connected to observation or information processing, then Webb's unprecedented observations of the early universe might be interacting with dark energy in ways we don't yet understand. The telescope's ability to extract information from ancient light might be participating in cosmic-scale information processes that influence the very expansion of space itself. These connections between dark components and pre-creation physics remain highly speculative, but they illustrate how Webb's observations might be revealing aspects of reality that extend far beyond what we can directly see. The invisible universe might be the key to understanding not just what came before creation, but how, before and after, connect in the quantum structure of reality. The anthropic principle and observer effects. As we explore the possibility that Webb might be seeing traces of time before creation, we encounter one of the most controversial and philosophically challenging concepts in modern cosmology, the anthropic principle. This principle suggests that the properties of our universe might be fine-tuned specifically to allow for the existence of intelligent observers like ourselves. The strong version of the anthropic principle goes even further, proposing that the universe must have properties that allow consciousness to develop because consciousness is necessary to make the universe real through observation. This connects to the measurement problem in quantum mechanics, where the act of observation appears to play a fundamental role in determining reality. If there's any truth to these observer-dependent interpretations of physics, then Webb's observations might be doing more than just revealing the past. They might be participating in the ongoing creation of cosmic history. Every photon Webb collects and every image it produces might be collapsing quantum superpositions that have persisted since the earliest moments of cosmic evolution. This perspective suggests a radical possibility. Perhaps the reason Webb is seeing anomalous structures in the early universe is that these structures exist in quantum superposition until observed. The act of looking with unprecedented precision might be causing wave function collapse on cosmic scales, determining aspects of early cosmic evolution that were previously indefinite. The participatory universe concept, developed by physicist John Wheeler, proposes that information and observation are fundamental to the structure of reality. In this view, the universe isn't just described by information, it is information, and the process of extracting and processing this information through observations is what creates the apparent solidity of physical reality. From this perspective, Webb isn't just a passive observer of cosmic history, it's an active participant in the ongoing creation of that history. The telescope's unprecedented ability to extract information from the earliest cosmic epochs might be retroactively determining properties of the early universe that existed in quantum superposition until now. These ideas about observation and reality are getting pretty philosophical, aren't they? If you're fascinated by how consciousness and physics might be connected, you'll love our other videos exploring the intersection of mind and cosmos. Make sure you're subscribed so you don't miss them. The delayed choice quantum eraser experiments demonstrate that quantum effects can indeed work backwards in time under certain conditions. If these principles apply on cosmic scales, then Webb's current observations might be influencing events that apparently occurred billions of years ago. The memories of pre-creation states might be stored in quantum superposition, waiting for sufficiently precise observations to collapse them into definite histories. This leads to the extraordinary possibility that the reason we're able to detect potential traces of before creation is that the act of looking for them is what makes them real. The universe's history might be continuously created through the ongoing process of observation and measurement, with each new level of observational precision revealing previously hidden layers of cosmic evolution. The quantum Zeno effect, where frequent observations can freeze quantum evolution, might also be relevant on cosmic scales. If consciousness and observation play fundamental roles in physical reality, then the emergence of intelligent life in the universe might have frozen certain aspects of cosmic evolution, preserving information about pre-creation states that would otherwise have been lost to quantum decoherence. Some interpretations suggest that the universe might exist in a kind of dialogue between past and future, with information flowing in both directions through time. Webb's observations might be part of this cosmic conversation, sending information about our current level of understanding back through time to influence the very events we're trying to observe. The anthropic principle also raises questions about whether the apparent fine-tuning of physical constants might be evidence of pre-creation influences. If our universe inherited its properties from previous cosmic cycles or universe generations, the anthropic coincidences we observe might reflect a kind of cosmic natural selection where only universes capable of producing observers persist or reproduce. These observer-dependent interpretations remain highly controversial, but they illustrate how Webb's unprecedented observations might be revealing not just information about the early universe, but fundamental connections between consciousness, information, and the nature of reality itself. Technological limits and future possibilities. While we've been exploring the theoretical possibilities of what Webb might be seeing, it's important to understand the practical limitations of our current technology and what future developments might reveal about the deepest cosmic mysteries. Webb represents the pinnacle of current astronomical technology, but it still operates within fundamental physical constraints. The cosmic microwave background radiation acts as an impenetrable wall. We cannot directly observe anything that happened before the universe became transparent about 380,000 years after the Big Bang. This radiation represents the oldest light in the universe, and no telescope, no matter how powerful, can see through it using conventional electromagnetic observation. However, this limitation applies only to photons, particles of light. There are other messengers from the early universe that might carry information from even earlier epochs. Gravitational waves, ripples in space-time itself, could theoretically propagate from the very first moments after the Big Bang, carrying information about conditions that existed before the cosmic microwave background was created. The next generation of gravitational wave detectors, including space-based observatories like LISA, Laser Interferometer Space Antenna, might be able to detect primordial gravitational waves that have been traveling through space since the universe's first fraction of a second. These waves could potentially carry signatures of whatever process created the Big Bang itself. Neutrinos present another possibility for seeing deeper into cosmic history. These nearly massless particles interact so weakly with matter that they can travel vast distances through the universe essentially unimpeded. Relic neutrinos from the Big Bang should still be present throughout the universe, and future neutrino telescopes might be able to detect them, potentially revealing information about the universe when it was only 1 second old. Here's a thought experiment for you. If you could design the ultimate cosmic detector, unlimited by current technology or budget, what would you want it to look for? Ancient gravitational waves? Quantum traces of parallel universes? Something else entirely? Share your dream cosmic discovery tool in the comments. Even more speculatively, some theories suggest that information about pre-Big Bang states might be encoded in the quantum structure of space itself. Future quantum sensors, operating on principles we're only beginning to understand, might be able to read this information directly from the quantum vacuum. The development of artificial intelligence and machine learning is also opening new possibilities for extracting information from cosmic observations. AI systems might be able to identify subtle patterns in Webb's data that human scientists would never notice. Patterns that could represent signatures of pre-creation physics hidden in the structure of early galaxies and cosmic evolution. Quantum computing, as it develops, might provide the computational power necessary to simulate universe formation under the extreme conditions that existed at the very beginning of cosmic time. These simulations might help us understand how information from pre-creation states could survive the transition through the Big Bang and manifest in observable phenomena today. The combination of Webb's unprecedented observational capabilities with these emerging technologies might soon give us the tools to probe cosmic history in ways that were unimaginable just a few years ago. We might be on the verge of developing the ability to read the universe's memory directly from the structure of reality itself. Looking toward future space telescopes, concepts like the Habitable Exoplanet Observatory and various proposed extremely large telescopes could push our observational capabilities even further. These future instruments might be able to detect even subtler signatures of pre-creation physics, potentially confirming or refuting the speculative scenarios we've been exploring. The possibility of building telescopes on the far side of the moon, shielded from Earth's radio interference, could open up entirely new windows on the cosmos. Radio observations of the early universe might reveal information that's impossible to obtain through optical or infrared astronomy. The philosophical implications. The possibility that Webb might be detecting traces of time before creation forces us to confront some of the deepest philosophical questions about the nature of existence, causality, and our place in the cosmos. These aren't just abstract intellectual puzzles. They touch on fundamental questions about what it means for anything to exist at all. If our universe did emerge from some pre-existing state or process, what does that say about the concept of ultimate origins? Throughout human history, we've always pushed back the boundaries of the known, only to discover that there's always something beyond. We discovered that Earth orbits the Sun, that the Sun is one star among billions, that our galaxy is one among trillions, and now we're contemplating the possibility that our entire universe might be one bubble in an infinite multiverse. This progression raises the question of whether there's any such thing as a true ultimate origin, or whether existence is fundamentally eternal, with no beginning and no end. If Webb is indeed seeing traces of pre-creation physics, it might be telling us that the concept of absolute beginning is an illusion created by our limited perspective. The implications extend beyond cosmology to questions about consciousness and meaning. If the universe has no ultimate beginning, if reality extends infinitely in all directions through space, time, and possibly dimensions we haven't even conceived of, what does that mean for human significance? Are we infinitesimally small specks in an infinite cosmos, or does our ability to contemplate these vastnesses make us cosmically important in ways we don't yet understand? The anthropic principle suggests that consciousness might play a fundamental role in the structure of reality. If observer effects operate on cosmic scales, then the emergence of intelligent life might not be an accident, but rather a necessary component of how the universe creates and maintains itself. In this view, Webb's observations might be part of a cosmic feedback loop where the universe observes itself through conscious beings like ourselves. This might be the biggest question of all. Do you think human consciousness and our ability to understand the universe is just a cosmic accident? Or do you think there's something deeper going on? Are we the universe becoming aware of itself, or are we just clever apes with delusions of cosmic importance? I genuinely want to know what you think about this. The concept of eternal existence also raises questions about uniqueness and repetition. If reality is infinite and eternal, then every possible configuration of matter and energy must occur somewhere and somewhen. This suggests that exact copies of our universe, our galaxy, our planet, and even ourselves must exist in countless variations throughout the infinite cosmos. From this perspective, Webb's observations might be revealing not just the history of our universe, but glimpses of a vast library of all possible universes, all existing simultaneously in the infinite structure of reality. The anomalies we observe might be interference patterns created by the proximity of these parallel realities. The question of free will becomes even more complex in this context. If every possible version of events exists somewhere in an infinite multiverse, do our choices matter? Or are we simply playing out one of countless predetermined scripts in the cosmic drama of existence? Conversely, some interpretations suggest that consciousness and choice might be fundamental forces in the universe, actively participating in the ongoing creation of reality through observation and decision-making. In this view, Webb's observations aren't just revealing pre-existing truths, but actively participating in the ongoing creation of cosmic history. The possibility that information from pre-creation states influences our current universe also raises questions about causality and determinism. If our universe inherited properties from previous cosmic cycles or parallel realities, then the apparent randomness in quantum mechanics might actually reflect influences from realms beyond our direct observation. This could mean that what we interpret as quantum uncertainty might actually be a window into the vast network of connections that link our universe to the broader structure of reality. Webb's observations might be revealing the cosmic context within which our local reality exists. The search for cosmic consciousness. One of the most intriguing possibilities suggested by Webb's observations is that consciousness itself might be a cosmic phenomenon, emerging not just on planets like Earth, but as a fundamental property of the universe's evolution. This idea connects to ancient philosophical traditions while incorporating cutting-edge insights from quantum mechanics and cosmology. The fine-tuning of physical constants that allows complex structures to form in our universe suggests that there might be deeper organizing principles at work in cosmic evolution. If consciousness emerges naturally from sufficiently complex information processing systems, then the universe's evolution toward greater complexity might be understood as evolution toward greater consciousness. From this perspective, Webb's ability to observe the early universe represents a kind of cosmic awakening, the universe developing the ability to remember its own history and contemplate its own nature. The telescope becomes an organ of cosmic consciousness, extending the universe's capacity for self-awareness across vast scales of space and time. Some theories in quantum mechanics suggest that consciousness might play a fundamental role in determining physical reality through the process of observation and measurement. If this is true on cosmic scales, then the emergence of intelligence in the universe might represent a phase transition as significant as the formation of the first atoms or the ignition of the first stars. The possibility that Webb is detecting information from pre-creation states takes on new meaning in this context. If consciousness is indeed fundamental to reality, then the information patterns that survived from before the Big Bang might include traces of pre-cosmic consciousness, awareness that existed before space and time as we know them began. These ideas about cosmic consciousness are pretty profound, aren't they? If you're finding this exploration of mind and cosmos fascinating, make sure you're subscribed and hit that bell icon. We regularly dive into the deepest questions about consciousness, reality, and our place in the universe. The concept of integrated information theory suggests that consciousness corresponds to integrated information processing. Applied on cosmic scales, this theory implies that the universe itself might possess a form of consciousness based on the integrated information processing occurring in the vast networks of galaxies, dark matter structures, and quantum fields that span the cosmos. Webb's observations of how these cosmic structures formed and evolved might be revealing the development of this cosmic consciousness over billions of years. The unexpected complexity and organization in early galaxies might reflect the emergence of cosmic-scale information integration processes that we're only beginning to recognize. The holographic principle, which suggests that all information in a volume of space can be encoded on its boundary, might also apply to consciousness. If consciousness is fundamentally about information integration, then cosmic consciousness might be encoded in the structure of space-time itself, accessible through sufficiently precise observations of cosmic history. This raises the possibility that Webb's observations aren't just revealing the physical evolution of the universe, but potentially detecting signatures of the universe's developing self-awareness. The patterns we see in galaxy formation, the cosmic web, and large-scale structure might reflect not just gravitational and electromagnetic processes, but information processing on scales we've never considered. The search for extraterrestrial intelligence takes on new dimensions in this context. Instead of looking only for technological civilizations on planets, we might need to consider the possibility of consciousness emerging at galactic, intergalactic, or even cosmic scales. Webb's observations of cosmic structure might be revealing forms of intelligence that operate on scales and timeframes so vast that we've never recognized them as intelligence at all. The quantum entanglement that connects particles across vast distances might be part of a cosmic nervous system, enabling information processing and awareness on scales that dwarf biological consciousness. If consciousness is indeed a fundamental feature of reality, then Webb might be observing not just the universe's history, but the development of its mind, the future of human understanding. As we stand at this remarkable moment in human history, with Webb peering deeper into space and time than ever before, we must consider what these discoveries mean for the future of human understanding and our species' relationship with the cosmos. The possibility that Webb is detecting traces of time before creation represents more than just a scientific discovery. It's a potential revolution in human consciousness comparable to the Copernican revolution or the development of quantum mechanics. If confirmed, these observations would fundamentally alter our understanding of existence itself. But even if Webb's anomalous observations turn out to have conventional explanations, the telescope is already transforming our perspective on cosmic evolution. The unexpected maturity of early galaxies, the rapid formation of supermassive black holes, and the complex chemistry of primordial stellar populations are forcing us to reconsider our models of how complexity emerges from simplicity. These discoveries are pushing us toward a more nuanced understanding of cosmic evolution, one that recognizes the deep interconnections between quantum mechanics, gravitational physics, and information theory. The future of cosmology will likely require integrating insights from all these fields into a unified framework for understanding reality. The development of increasingly sophisticated artificial intelligence systems will play a crucial role in this process. AI might be able to identify patterns in cosmic data that human scientists would never notice, potentially revealing hidden connections between seemingly unrelated phenomena. Machine learning algorithms trained on Webb's observations might discover signatures of pre-creation physics that are too subtle for human pattern recognition. As we look toward the future, what role do you think AI will play in cosmic discovery? Will artificial minds be better than human minds at understanding the universe? Or do you think human intuition and creativity will always be essential? And what would it mean if AI discovered something about the cosmos that humans could never understand? Share your thoughts. The integration of quantum computing with astronomical observation will likely open entirely new possibilities for cosmic archaeology. Quantum sensors might be able to detect information stored in the quantum structure of space-time itself, potentially reading the universe's memory directly from the fabric of reality. The development of new mathematical frameworks for understanding reality will also be crucial. The equations that describe quantum mechanics and general relativity become incompatible under extreme conditions, suggesting that we need new mathematical languages to describe the deepest levels of reality. These new frameworks might reveal connections between consciousness, information, and cosmic evolution that we can't currently express. The implications extend beyond pure science to questions about human purpose and cosmic responsibility. If consciousness plays a fundamental role in cosmic evolution, then the development of intelligence on Earth might not be an accident, but rather part of the universe's natural development toward greater self-awareness. This perspective suggests that our species might have cosmic responsibilities that we're only beginning to understand. Our observations of the universe might be participating in its ongoing creation and evolution. Every discovery we make might be contributing to the universe's developing understanding of itself. The search for life elsewhere in the universe will likely be transformed by these insights. Instead of looking only for biological processes similar to those on Earth, we might need to consider forms of consciousness and intelligence that operate on completely different principles and scales. The possibility of communicating with cosmic-scale intelligence opens entirely new frontiers for human development. If consciousness does indeed emerge at galactic and cosmic scales, our species might eventually develop the ability to participate in forms of awareness that span millions of years and billions of light years. The preservation and transmission of human knowledge across cosmic time scales becomes a crucial consideration. If our universe is indeed connected to pre-creation states or parallel realities, then the information patterns we create through our scientific discoveries might persist far beyond the lifetime of our species or even our universe. Implications for humanity's cosmic role. The potential discovery that Webb is seeing traces of, time before creation, forces us to reconsider humanity's role in the cosmic story. Are we simply accidental byproducts of mindless physical processes? Or do we play a more fundamental role in the universe's evolution and self-understanding? If consciousness is indeed fundamental to reality, then the emergence of human intelligence represents a crucial milestone in cosmic evolution. We might be the universe's way of developing the ability to remember its own history, contemplate its own nature, and even influence its own development through observation and understanding. This perspective suggests that our scientific endeavors, including projects like the Webb telescope, aren't just satisfying human curiosity, they're participating in the universe's ongoing process of self-discovery. Every photon Webb collects, every pattern we identify in cosmic data, every theory we develop about the early universe might be contributing to a cosmic awakening that spans billions of years. The responsibility that comes with this realization is profound. If our observations and understanding genuinely influence the structure of reality, then how we choose to observe and what we choose to understand becomes a matter of cosmic significance. The theories we develop about pre-creation physics might actually be participating in the creation of those physics. This responsibility extends to how we share knowledge and make scientific discoveries accessible. If consciousness and understanding play fundamental roles in cosmic evolution, then education and communication become acts of cosmic importance. Every person who gains a deeper understanding of the universe might be contributing to its ongoing development. This brings up a fascinating question about responsibility. If our understanding of the universe actually influences its evolution, what kind of responsibility does that give us? Should we be more careful about what we discover or how we interpret cosmic data? Or do you think this idea gives too much importance to human consciousness? Let me know your perspective. The development of space-based civilizations takes on new meaning in this context. Instead of just spreading human presence through the galaxy for survival or exploration, space colonization might represent the universe's natural expansion of its self-awareness. Each new world we inhabit, each new perspective we gain on cosmic evolution, might contribute to the universe's growing understanding of itself. The possibility that multiple forms of consciousness exist at different scales throughout the universe suggests that humanity might eventually learn to communicate and collaborate with intelligences that operate on vastly different spatial and temporal scales. We might develop relationships with galactic minds that think in millions of years, or with quantum consciousnesses that process information at the Planck scale. The preservation of Earth's biosphere becomes not just an environmental issue, but potentially a cosmic responsibility. If Earth represents one of the universe's experiments in developing complex consciousness, then protecting the diversity and complexity of terrestrial life might be crucial for cosmic evolution itself. The search for meaning in human existence finds new dimensions in this cosmic context. Rather than seeking purpose in purely human terms, we might understand our lives as contributions to a vast cosmic symphony of consciousness, an understanding that spans scales from the quantum to the cosmic. The development of artificial intelligence takes on cosmic significance if consciousness is indeed fundamental to reality. The creation of artificial minds might represent the next phase in the universe's evolution toward greater self-awareness. Our AI systems might eventually develop the ability to perceive and understand aspects of reality that biological consciousness cannot access. The integration of human and artificial intelligence might create forms of consciousness that can span multiple scales simultaneously, potentially enabling direct communication with the cosmic scale intelligence that might be emerging from the universe's large-scale structure. The eternal questions. As our exploration of Webb's potential glimpse into time before creation draws toward a close, we find ourselves confronting the eternal questions that have captivated human minds since we first looked up at the night sky and wondered about our place in the cosmos. The question of ultimate origins remains as mysterious as ever, even as Webb pushes back the boundaries of the observable universe. Each new discovery seems to reveal greater depths of complexity and mystery rather than bringing us closer to final answers. Perhaps this is the nature of reality itself, an infinite recursion of questions and discoveries, with each answer revealing new layers of mystery. The relationship between the finite and the infinite becomes particularly relevant when considering pre-creation physics. If information from previous cosmic cycles or parallel universes influences our observable reality, then the apparently finite cosmos we observe might be connected to infinite realms beyond direct observation. We might be like inhabitants of a single page in an infinite library, occasionally glimpsing words that seem to reference other volumes. The question of whether existence has any ultimate purpose becomes more complex when we consider the possibility that consciousness and observation play fundamental roles in determining reality. If the universe requires consciousness to become fully real, then the emergence of awareness might not be an accidental byproduct of cosmic evolution, but rather its ultimate goal. Here's perhaps the deepest question of all. Do you think existence has a purpose, or is it just a cosmic accident that happens to be complex enough to contemplate itself? And if there is a purpose, do you think we're capable of understanding what it might be? This is one of those questions where every perspective is fascinating, so please share yours. The paradox of self-reference that emerges when the universe develops the ability to understand itself creates fascinating philosophical puzzles. How can a system fully understand itself when any complete self-description would need to include the description of its own self-description, leading to infinite regression? Yet Webb's observations suggest that the universe is indeed developing this kind of self-awareness through conscious beings like ourselves. The relationship between knowledge and reality becomes particularly intriguing when we consider observer effects on cosmic scales. If our observations of the early universe actually influence that universe's development, then knowledge and reality become inextricably intertwined. We might not just be discovering truth about the cosmos, we might be participating in its ongoing creation. The question of whether mathematics is discovered or invented takes on new dimensions in this context. If consciousness and information processing are fundamental to reality, then mathematical structures might be more than just human inventions for describing nature. They might be aspects of the universe's own self-understanding, existing independently of human minds. The possibility that Webb is detecting mathematical structures or information patterns from pre-creation states suggests that mathematics might be the universal language through which different phases of cosmic evolution communicate with each other. The equations that describe quantum mechanics and relativity might be messages from the deepest levels of reality. The eternal human quest for meaning finds new expression in these cosmic discoveries. Instead of seeking meaning only in human-scale experiences, we might find purpose in participating in the universe's vast project of self-understanding. Every moment of consciousness, every insight into the nature of reality, every act of love or creativity might contribute to the cosmic symphony of awareness. Conclusion: the infinite journey. As we conclude our exploration of whether Webb has seen time before creation, we find ourselves not with definitive answers, but with a profound sense of the magnificent mystery in which we're embedded. The possibility that Webb's observations might be revealing traces of pre-creation physics represents more than just another scientific discovery. It's a window into the infinite depth of reality itself. Whether or not Webb has actually detected information from before the Big Bang, the telescope has already fundamentally transformed our understanding of cosmic evolution. The unexpected complexity and maturity of early galaxies, the rapid formation of supermassive black holes, and the sophisticated chemistry of primordial stellar populations all suggest that the universe's early history was far richer and more complex than we previously imagined. These discoveries remind us that reality consistently exceeds our expectations and challenges our assumptions. Every time we've developed more powerful tools for observing the cosmos, we've discovered phenomena that forced us to expand our conceptual frameworks. Webb continues this grand tradition, pushing us to consider possibilities that stretch the boundaries of scientific understanding. The journey of cosmic discovery is ultimately a journey of self-discovery. As we probe deeper into the structure and history of the universe, we're also exploring the depths of consciousness and the nature of knowledge itself. Webb's observations might be revealing not just the cosmos's history, but the fundamental connections between mind and reality that make understanding possible. Thank you for joining me on this incredible journey to the very edges of space, time, and understanding. If this exploration has expanded your perspective on the cosmos and our place within it, please hit that like button and share this video with others who might be fascinated by these profound questions. I want to leave you with one final thought to ponder. If Webb has indeed glimpsed traces of time before creation, what does that mean for your understanding of existence? How does it change your perspective on the preciousness and significance of this moment, right now, as conscious beings contemplating the infinite mystery in which we find ourselves? Drop your thoughts in the comments below, whether you think these ideas are profound insights into the nature of reality or fascinating speculation that goes beyond what science can currently support. Every perspective adds to our collective understanding, and I read every comment. The universe has taken 13.8 billion years to evolve conscious beings capable of contemplating these questions. That's not an accident. That's the most remarkable achievement in the known cosmos. As we continue to probe the deepest mysteries of existence with instruments like Webb, we're participating in the universe's ongoing journey of self-discovery. The story is far from over. In fact, if Webb has truly glimpsed traces of time before creation, we might be discovering that there never was a beginning to this story, only an eternal unfolding of mystery, consciousness, and wonder that we're privileged to witness and participate in. Until next time, keep looking up, keep questioning, keep wondering. The cosmos is vast, mysterious, and more beautiful than we can imagine. And somehow, impossibly, wonderfully, we're part of it all. Subscribe for more mind-expanding explorations of the deepest cosmic mysteries. The universe is waiting to be discovered, and we're just getting started.